finding the intersection of two functions. Now, if I'm in a calculus class, by the way, it's not unusual that I might want to find, say, the area between these two graphs, which might be this thing right here. And the calculus processes, I would need to know the x values here and here. In order to set up the process, I would need the x values, and therefore I need to know where they intersect. Graphically speaking, this one's easy because it looks like it intersects at x equals 0 and x equals 4. But the majority of time when you're doing applications ain't so easy. So that says, if I look at the visual solution, to me visually, because this is y equal 3, and this is y equal x cubed minus, or x squared, minus 4x plus 3. So from a visual solution, it looks like it is x equals 0, y equals 0, or you could just say x equals 0, depending upon what they're looking for. In this particular instance, it looks like we're just finding the x values. And the other one would be x equal 4, y equal 3. Now, it's not 0, 0. I just screwed up right here. What should this be? This is the point of intersection. What should this have been? Yeah, 0, 3. And so from an x coordinate point of view, it would be 4. We're going to have in chapter 6 where we're going to actually have to find the coordinate points. But from all appearances, all they want us to do is to find the x values. So that's if I solve this by using algebra, I should come up with an x value of 0 and an x value of 4. 99% of the time, you will do a lot of this stuff by substitution, but the way this thing is going to be phrased is this. If I'm looking for the intersection, what I want is where f of x equals g of x. In other words, that's where they have the shared coordinate points. It's where the two graphs cross. And if f of x equals g of x, that would say that x squared minus 4x plus 3, that's f of x, equals g of x equals 3. That now gives me an equation that I can solve. A quadratic means we bring everything to the same side and 0 on the other. So x squared minus 4x, subtract 3, the 3's are gone, equals 0. Now what do I need to do? I could use a quadratic formula on it, but I don't need to, because it's quadratic, right? But what could I do? Well, I could complete the square on it too. But what would be an easier thing to do? Take out an x. It's got a GCF of x. But everything that you said will work. You can come at the solutions from a bunch of different directions. You can complete the square on it. You can use the quadratic formula on it. You can factor it if it factors. It all works. That's the beauty. You're not stuck with one way to work the problem. And if you can't remember that way, you're screwed. Right? So this says x equals 0, x minus 4 equals 0, or x equals 0, or x equals 4. Is that not what I got visually? Yeah. And that says those are the x coordinates that the two graphs have in common. And if I were in a calculus class, then I would set it up, the process x equals 0 to x equal 4. And then I'd find the area that's bounded. Now, again, we want to know where f of x equals g of x, or where x squared plus 5x minus 3 equals 2x squared plus 7x minus 27. Take everything to one side, 0 on the other, and let's pray that it factors. So 0 equals, subtract x squared from both sides, subtract 5 from both sides, add 3 to both sides. Woohoo! It factors, yay! Otherwise, what would I have to do? Use a quadratic formula, complete the square, but it does factor. So 0 is equal to x plus 6, x minus 4, or x is negative 6, x is positive 4. Now those are the two x values. And then if I want to find the y value, I could go back to either one of these original functions to find the y value. But that would be the shared x and y, because it's the intersection of the two graphs.